Wanted to give you an idea of what project 3 might have been. This is the project that never was. We cut it out because we had to cut out some things for the class. And so I'm going to make some connections between finance and the statistical regression that we're doing in this class. Okay, so give you a 3-minute corporate finance course. Let's talk about the capital asset pricing model. Stocks is where you buy a share of the company, and so you are taking on their risk, but also reaping their benefits either through dividends or whatever. You have to know that stocks are risky. A particular stock will have a certain amount of risk associated with it, and there are actually two kinds of risks. It's mostly boiled down to one is market risk. These are the prices, not the princes, in the stock market as a whole. Sometimes this is called systematic risk or non-diversifiable risk. For an individual stock, the market risk will be related to the general factors that affect the overall economy. So as everyone does well, might mean that this particular stock will do well or not. Non-market risk, this is the risk associated to a stock or group of stocks because of the specific nature of the stock's industry group and the position of issuing corporation in that industry. So, you might be making RVs in Elkhart, Indiana. That specific nature has risk depending upon certain other things, or maybe Boeing in an airplane flight. If something goes up, then they benefit, or if something goes down, they worsen. All right, so let's talk about diversifiable risk. Diversifiable risk, because it depends on sort of certain sectors, you can manage this by choosing the mix of stocks in the overall portfolio. This is what's called diversification, and why you do diversification, so you don't have all your eggs in one basket. The overall market performance can be measured by such indices as the Dow Jones or Standard & Poor's or Russell 4000 or all sorts of other indices. If an investor's portfolio exactly matches that used to measure the overall market performance, then the risk of the portfolio will be entirely market risk. Generally, the market and non-market risk are assumed to be independent. So, in general, maybe at a baby step, the total market risk is the market risk plus the unsystematic risk. Market risk is what's, everybody's in the same boat, and whatever that risk is, we're all in the same boat. Unsystematic risk is, hey, I'm in this certain sector, and so if something bad happens in sector B, then I might be in trouble. If something happens, I might be in better shape. So you can eliminate unsystematic risk just generally by diversification. And generally, if you have a relatively large portfolio, you have almost no unsystematic risk. Now, systematic cannot be risk because you're talking about the total market. So just by definition, you cannot eliminate that. So there are no bonus points for unsystematic risk. So just because you have risk doesn't mean you should be rewarded with better returns. Now, most of the time you are rewarded for taking on risk, but since you can eliminate it by diversification, there's no reward for bearing unsystematic risk, and the market does not reward risks that are taken on unnecessarily. So a fool and his money are soon parted, so to speak. So how do we measure it? And this is really a crucial determinant of an asset's expected return, and we need a way of measuring it, and let's talk about how we might do that. The specific measure for market risk is often called the beta, or the beta coefficient. And beta tells us how much market risk a particular asset has relative to an average asset. An average asset will have a beta of 1. An asset of a beta of 0.5 will have half the risk. A beta with 3 will have 3 times risk of the average asset, with the idea that if the stock market goes up, you should see a 3 points higher return. If the stock market goes down, it might mean you have 3 times the loss. So generally, we represent the risk by standard deviation of the return sigma, also called the volatility, sigma and beta. Where have I seen that before? So here are some examples of betas. I've got this yesterday from Yahoo Finance. Generally, assets with larger betas have higher systematic risks and so have higher expected returns, and so there's one indication if you're a technical analyst of whether you should invest in a stock or not. So here's the setup. Let RS be the random return on the stock for a period under consideration, and RM, M for market, be the random return on the entire market for the period. And let this alpha S be part of the return not related to the market, and then let beta S be the expected change in the random return given a change in unit of the market return, and let epsilon S be a random variable with mean 0 measuring the non-market risk. So let's interpret these in terms of Math 382. Let alpha s be the part of the return not related to the market. If the market has no effect, then perhaps this could be the y-intercept. Beta s, the expected change in return given a change of 1 unit. This certainly sounds like a slope. And epsilon with mean 0 measuring the non-market risk. Remember we said the risk was standard deviation. So this sounds like our error random variable with mean 0 constant standard deviation. Now normally distributed, which is kind of assumed, but that's may not match up with reality. But most of the time it does. So let beta s be the expected change in RS, the return of the stock given a change of 1 unit in the market return. So we're going to call this beta s the beta of a stock. And this is going to act like a parameter. And our estimates for slopes were generally represented by beta hat or by BS. The expected value of our estimates for the slope would end up being beta s. And this is what's reported in the stock. So what we have here is the stock's characteristic line. The larger the beta of a stock, the larger the expected return, larger the risk, and larger and steeper the slope. So that's our model, alpha s plus beta s Rm plus epsilon. I don't know if you remember that on your calculator. If you look at it, you fit an equation that y is equal to a plus bx is one of your choices, and kind of goes back to statistics that a's parameter would be alpha. And our estimate will be the mean, that's where the bar is over the stock return, and that's equal to our estimate for alpha plus our estimate for beta times the mean return of the stock market. So how do we estimate it? So we use statistical regression on historical data and fit that there. So in general, what you do is you don't just take the return of the stock, you compare that, well, what could you have done with that stock just to put it in the bank and earn interest, sort of like the parable of Jesus. Least of you do throws them out, gnashing of the teeth, all that stuff. You could have put it in the bank and earned interest. So that's the safest thing you could do. You can at least earn that. So if, say, you have 1% safe return and your stock return is 6%, 6% minus 1% would be 5%, would be the excess return. So anyway, you can plot all those and look at the market return and the return on the stock and fit an equation for that, and that will give you both your alpha and your beta. And that can then lead you to the capital asset pricing model, again, where you have this risk-free interest rate, and you can modify that to set up that equation. And this is kind of the example where the y is the realized excess return on the asset and the excess return on the market portfolio, and you have some below and above the line. And that's the characteristic line. The intercept then is the alpha, and the slope is the beta. Now, just remember, anytime you look at a line, make sure you look at the axes to determine what's measured there. And most corporate finance illustrate the security market line, where the systematic risk is on the x-axis, and that's the beta. And then the expected return of your asset is on the y-axis. So, for example, the risk-free interest rate is RF because the beta is 0, because there's no risk whatsoever to put your interest into cash, or into a money market or into a savings account, which, I'm sorry for using the word cash because that's usually how we talk about this. And then if you have a systematic risk of 1, then your expected return of your of the market will be M. And then you have an undervalued stock if the expected return is above the security market line, an overvalued stock if it's below the line. Anyway, so just make sure that you look at the how the X and Y axis are labeled for this. Anyway, you can find more about this in Investopedia, and this is something that we would have done in your Project 3, but hopefully you can still make the connections between the two.